Hey guys, welcome back to another video. In today's video, we are going to be having a look at chemical energetics. This is part of the chemistry series that is being ongoing. Sorry for not uploading as much, but I'm trying my best to upload as much as I can in my channel. I'm trying to, of course, spread out all the content with the various subjects. Anyway, so this is chapter 6, chemical energetics, and in this chapter we basically talk about reactions. We talk about energy that is needed for these reactions to take place, the energy that's given out, the energy that's needed. So we'll have a look at everything in today's video. So first of all, I want to bring you to a term that you must have heard of, because this was done in the starting stages of chemistry. We have the physical and the chemical changes. Okay, now we start off with this because this is, of course, the basics. We have something called the physical change and a chemical change. So when we're talking about the physical change is one which no new substance is formed. So the key thing you need to take from this is no new substance is produced. Okay, so with the physical change, there's no new substance that is producing, and an example would be melting, boiling, condensing, freezing, and basically those are all physical changes. Okay, now these physical changes also are reversible. Okay, reversible basically means I can do a reaction and then get that same reactant back. Okay, because of course we have products, okay, and we have reactants. Okay, this is how the chain works. So with the reversible reaction, I can make the reactants to product and the products to reactants. That is basically what a reversible reaction is. But on the other hand, what is chemical reactions, or what are chemical changes? With chemical changes, basically new substances are produced. Okay, so new substances are produced. So with new substances that are produced, some examples could be maybe when you can react magnesium with oxygen, which will basically form magnesium oxide. We are forming magnesium oxide, and this magnesium oxide is a new substance, and hence it will be a chemical change, because I cannot change this magnesium oxide back to magnesium and oxygen. Hence it is a chemical change. So I would like to introduce you to this topic with the following, and I'm sure you've already heard of this, but I'm just reminding you. So physical changes and chemical changes, every reaction can be either physical change or a chemical change. So basically that's really it about physical and chemical changes. We move on to another subtopic, and this subtopic would be about exothermic reactions and endothermic. Now, maybe you might not know what these terms are for now, but basically, whenever a reaction takes place or during a chemical reaction, there is always energy change. Okay, there is always energy change. Now, energy can be either given out or taken in, and usually this energy is in the form of heat. Okay, now this form of energy can be divided into two groups, and the two groups you would guess would be the exothermic and the endothermic. Okay, those are the two groups we can classify this energy change. Now these are just reactions, okay, that you can classify them with either exothermic or endothermic. So let's start off with the first one, the exothermic. What is an exothermic reaction? An exothermic reaction is when the heat, or basically when you give out energy. Okay, so when you give out energy, which mostly is heat, but when you give out energy, and because you're giving out energy, there will be a temperature rise. Okay, there will be a temperature rise in these exothermic reactions. Now, an exothermic reaction gives out heat because, of course, energy, I told you, is usually in the form of heat. So it will give out heat, and the total chemical energy of this reactant is larger than the product. That means that the reactants, okay, the reactants of this reaction will be the products, of course, plus additional energy, because it is an exothermic reaction. Okay, hence this side would be greater than the reactant side. Now you can basically show this exothermic reaction with the help of a graph. Okay, so let me show you how this graph is done, and you need to memorize how this graph looks like. So this graph is called the energy level diagram, and I'll try my best to actually let me just try screenshot it and show you guys here instead of me drawing it, which would be worse. Okay, so let me show you how this looks like. So basically it's just a simple diagram that shows you about the reactants and the products and how it basically works. Okay, so let me just quickly paste it right here, and yeah, there you go. So it's here, and basically, as you guys can see, this right here is in fact the energy level diagram. Sorry for the blurriness, but basically we have the energy on this side. Okay, let me rub this. We have the energy on this side, we have the reactants, and it is going down because why? Energy is given out, because it is an exothermic reaction, so it's given out, and hence it will be in a structure like this because it's given out. Okay, and then of course we have the products. So this is how the exothermic reactions work. Now, with that being said, let's move on to energy change. Okay, what is energy change? We know that energy is measured in joules or kilojoules for a reaction. Okay, and usually in these types of questions, beside the equation, you will be given the energy change. Okay, that means maybe energy change, they will give you negative 100 kg, for example. Now, this 100 kg of energy is given out when the amount of reactants in the equation, okay, is a certain amount, and then they react. So meaning the reactants react, and then they will form an energy change of negative 100 kg. Okay, and this minus sign that you see right here is shown that energy is given out. So you need to remember that whenever you see a minus, it means it is an exothermic reaction. Okay, so that is how you can remember when your reaction is either exothermic or when your reaction is endothermic. Now, with that being said, that is all about the exothermic reaction. What about the endothermic reaction? Okay, so we also have the endothermic reaction. Now, the endothermic reaction is when the heat is taken in from the surroundings. Okay, with exothermic it was released. In this case it is taken in. Okay, so an endothermic reaction takes in heat. Okay, and the chemical energy of the reactants is smaller than the product. Okay, this again because it becomes reactants plus energy. Okay, plus energy is equals to the product. So as you can see in the endothermic reaction, we have the reactants and energy is more than the products. Okay, this is how you can basically derive either it is an endothermic or an exothermic. Now, how would the graph for this look? Okay, the one, sorry, not the graph, but actually the energy level diagram is what it's called. So let me just again take a screenshot of this and show you guys how it looks. Now, it's almost the same, but instead it is the opposite way, meaning the energy is going up. So as you guys can see right here, everything is same. Energy the same here, reactants is the same, but now the product, the energy is taken in. That's why it's going up into the product. So that is how the energy level diagram for the endothermic reactions work. So I told you endothermic reactions, examples would be melting of ice, photosynthesis, reactions that take place in cooking. All of that is endothermic because heat is taken in. For melting in ice, the ice takes in heat and then melts. Okay, for cooking it takes in the heat to become hot, right? The food becomes hot by taking in heat, hence it is an endothermic reaction. Some examples of exothermic reactions would be maybe a reaction or maybe respiration, actually, because it provides the energy to keep your heart and lungs working. Okay, and therefore respiration has to give out that energy. Okay, that is an example of exothermic. So there you go. We've talked about endothermic, we've talked about exothermic. We've also talked about the physical change and the chemical change. Hopefully there is no question so far. With that being said, we move on to something called bond breaking and bond forming. Bond breaking and bond making. Now, we've been talking about energy. We've been talking a lot about the, energy. Now, in any chemical reaction, first of all, there's always energy, involved in this. But the second thing is something called bond, okay? And in a chemical reactions, bond must first be broken and then new bonds are formed. The process of this bond breaking is an exothermic reaction. So you need to understand whenever the bond breaks, okay, this is an exothermic reaction. Okay, but whenever the bonds are made, okay, when bonds are made, then it will be the endothermic reaction. So you can see everything is revolving around the exothermic reaction and the endothermic reaction. So for the bond breaking, the energy must be taken in, right, to break the bonds, and hence for this case it would be let go. So that might become quite confusing, because endothermic we know is when it takes in heat, but remember, for bonds, in the start I told you, for bonds to be made you have to first break them, okay? The bonds must be first broken and then the new bonds are formed. So for exothermic, the energy must be taken in first to break those bonds, okay? Sorry, it is actually the opposite. Sorry. Yeah, bonds broken is actually endothermic. Yeah, this is endothermic. Sorry about that. This is endothermic and this is exothermic. So what that means is that for endothermic, it needs heat to come in to break the bonds, and here it has to give out to break the bonds. Yeah, sorry about that. But the rest should be the same, okay? So sorry about that, but that is what it means. So endothermic is when it has to take in to break those bonds. Now, what are some examples and how are some exam style questions usually done? Okay, now usually you're given an equation, okay? You're given an equation, either stuff with bonds, right? So it would look like this. They would say H, okay, which is a bond, Cl equals to 2HCl, okay? We know this, okay? So this is, for example, the equation they can give you, okay? And then in the side, in the question, they say H is basically 436, then Cl is basically 242, and then of course HCl is 431. So with this that they usually provide, what you have to do is quite simple. You just have to add it. So here would be 436, here would be 242, and then here would be 431. After this, you would add this up, okay? And you would add this up. And to calculate the energy change, you always have to do energy in minus energy out. So energy in, which would be in this side, and energy out would be on this side. Basically, you would do, here the total will be 678, here the total will be 862. Okay, so you would do 678 minus 862, which will give you negative 184 kJ, okay, because this is energy. Okay, and you can also represent this on the energy level diagram. Because it is negative, it is an exothermic reaction, and we mentioned this previously on the actual thing. So how the bond energy would look, the energy diagram would look like this. Okay, energy in, it takes the energy out. Sorry, the bonds will be broken in and then will broken out, and then we have it like that. So here you're taking energy to break the bonds. Here you are letting energy out because it's an exothermic reaction. Okay, so this might be a bit complicated, but just for the start. Okay, that's how it basically works. Now, when talking about this, we also talk about fuels. Okay, so we also talk about fuels, and let me just confirm Yeah, we also do talk about fuels. Now, when talking about fuels, let me just clear the canvas. We basically have to talk about, first of all, what is this fuel? What is a fuel? Okay, what is a fuel? Now, a fuel is any substance we use to provide energy. Okay, and the most common way of producing heat energy is by burning fossil fuels. Okay, and I'm sure you've heard of fossil fuels. Fossil fuels, there are three fossil fuels, and these are natural gas, coal, and petroleum products. Okay, now the first thing you need to know is about fossil fuels, and we use these fossil fuels so that we can release heat. Okay, and maybe we can burn these fossil fuels in power stations and to heat water or something like that, to basically produce heat. So what makes a good fuel? Okay, why do you decide to use fossil fuels? Now, first of all, you need to know how much a fuel gives out energy. Is it good enough? How much energy does it provide? Next, does it cause pollution? Is it easily available? How much does it cost? Basically, all those factors will decide or will let you know either if the fuel is good or not good. Now, with talking about fossil fuels, you also have to know about nuclear fuels. Okay, nuclear fuels, on the other hand, are not burned. Okay, but instead they are contained of something called radioisotopes, which are unstable atoms, and over time they break down naturally, giving out radiation, which is a lot of energy. And this is actually stored or made in the nuclear power station. I'm sure you've heard of it. It's really expensive though. Okay, it's very expensive, but it gives out a lot of energy. And some of the advantages that you need to know is that it gives a lot amount of energy, and there's no CO2 or polluting gases that are made. But with the disadvantages is that power stations could spread radioactive materials, which is very dangerous. Okay, and this waste material that's produced in the nuclear power station is radioactive, which means it's very dangerous. Okay, and if you have watched the movie Chernobyl, you would know about nuclear fuels, because that was an example of radioactivity when it blasted and the radioactive particles basically moved around the place that everyone had to evacuate because it was dangerous. And also because they're so big, finding a place to store them is very hard. Now, with that being said, we move on to something called the hydrogen fuel cell. Okay, and I want to just show you a diagram of this so that you can understand what this hydrogen fuel cell means. But in simple terms, what the hydrogen fuel cell is, okay, it's basically just the combustion of hydrogen. Okay, now it's a combustion of hydrogen, and let me just show you a picture of how this works. Okay, how it works. So this right here is the hydrogen fuel cell, as you guys can see. So this is the hydrogen fuel cell. The hydrogen fuel cell. Okay, and you can see the fuel in, the air out. You need to memorize this. As you guys can see, this is the electric current right here that moves around the circuit. And what's happening is that we are supplying fuel in. Okay, hydrogen reacts. Okay, we are putting air on the other side. And what the main reason is this, okay, of you know what this is basically, it is used in rocket fuel, it is used in vehicles, and it's also used in fuel cells. Okay, this is a redox reaction, and the energy is given out. Of course, the main purpose we do this is for energy, so that we can get energy, right? And this is a simple setup that you need to know. Now you can see right here, because you've seen electrolyte, there is some presence of electrolysis. Okay, now we haven't covered electrolysis right now so far in this series, but we will talk about this later, and hence we will come back to this topic once again when talking about electrolysis. But for now, you need to know the advantages of why we use this hydrogen fuel cell, and the reason is because only water is formed, only H2O is formed, which and has no pollutants, which is such a big benefit. Also, this reaction will give out a lot of energy, and that's the reason why we use this. Okay, and finally, we will not run out of hydrogen, okay, because it can be made by electrolysis of water. Hence, it's a everlasting process of producing energy. So basically, this video tackled about how energy works, the different reactions, and hopefully you have learned. It was a quick video. This chapter is actually quite small. There's not a lot to talk about, But all you need to know is about physical changes, chemical changes. You also need to talk about endothermic, exothermic. We also will do later, after finishing the series, we'll do many past papers, because this topic is more of practice, because when we talked about bond breaking and bond making, it's quite simple, because they give you the bond. All you have to do is just add it up. Rarely are you supposed to make that reaction or make the reactants and products, but even if you do, they're quite simple because they give you the chemical formula. Okay, so with that being said, we have talked about bonds, we've talked about the different ways to produce energy and the disadvantages and advantages. We also talked about nuclear fuels, fossil fuels, and then finally we had a look at the hydrogen fuel cell. So we talked about the three ways energy is produced and why energy is so vital, because we use it in vehicles, we use it in almost everything. Okay, so that marks the end of the video. Hopefully you learned something, and I'll see you in the next video where we will be talking about chapter 7, and I believe chapter 7 talks about the rate of speed of a reaction, talks about equilibrium, and also we will cover physical and chemical changes once again in more in-depth. But I thought, introducing you to physical and chemical changes will help you to understand more of this chapter 6 topic. So with that being said, hopefully you enjoyed this video, and I'll see you in the next one. Goodbye.